Thanks for the invite. And today I'm going to talk about cloud computing and interactive mapping using Google's engine and Gmap. And also I will briefly introduce QGIS. The Google slides of this presentation can be accessed through the link here, lower right corner. You can scan the QR code using your cell phone, or you can type the URL gishub.org/NASA. I also put one in the chat box, so you can click the link to look at the slides if you want. And let me see here. This is the outline of my presentation. First, I will briefly introduce Earth Engine. So it's good to know that some of you already have the Earth Engine account, so they will save us some time. And then I will briefly introduce how to install the Geemap Python package. And I will introduce some of the documentation, tutorials, and also some of the key features of the package. And then I will introduce you Earth Engine apps. So after you develop your algorithm and you want to publish online so people can go to your website to see your products. So this is called Earth Engine app. And also we have the Earth Engine QGIS plugin. So you can use QGIS to access Earth Engine data and also display the Earth Engine results or computational results. On the right here, I show you this kind of animation. So this is something you can create using the Geemap Python package. And you don't need to write any line of code. You can go to the web app. If you click the hyperlink on the slides, it will take you to the web app. Also, you can look at the Jupyter Notebook, the source code behind of this app. At the end of the presentation, I also demonstrate this one on the fly, so you know exactly how to do this one, how to create animation like this. So this is very, very powerful and useful. You can create this kind of animation and then share on social media, or you can put this one onto your website. It doesn't have to be reverse. You can urban expansion, you can do deforestation, you can do temperature dynamics. So anything that you can think of that satellite data, you have time series, and you can create something like this. For example, for Landsat data for the past 30, 40 years, since 1984. Again, you don't need to write any line of code. You will be able to do this one after this presentation. So first, I would like to briefly talk about the difference between Google Earth and Earth Engine. So if you have not used Google Earth Engine before, I'm pretty sure you have used Google Earth in the past. So Google Earth is actually just like a virtual globe that you can view satellite imagery, you can navigate, you can see 3D buildings, but you cannot really do any analysis. So for example, if I ask you the question, we know that Las Vegas, the urban area is growing, right? If you can see from the satellite imagery, you know it's growing. But if I ask the question, how fast is it growing? If the urban area is growing, how much, how many acres or how many hectares is it growing? You cannot really use Google Earth to answer these kind of questions. On the other hand, Earth Engine is just like the compute engine behind Google Earth, so you can actually do analysis. In here, I give you a simple analogy. So Google Earth is just like image viewer on Windows system, right? You can use the image viewer to open an image, but can you do any analysis? Can you do processing? No, you can only view, but you cannot do analysis. Earth Engine is just like Photoshop. You can do all kind of complicated computation. You can crop the imagery. You can merge different photos together. You can do some filtering. You can have some filter or effects. So you can do all kind of cool stuff. So this is kind of brief distinction between these two, just to keep it in mind. And later on, you will understand like, oh, actually we can use this one to address some of the questions that you were not able to address using Google Earth. So here are the two links. Google Earth is free for research, education, and non-profit. You can go to the link, and then you can go to the upper right corner here to sign up and using your Gmail account or your edu email. One of the common applications for Google Earth Engine is to create cloud-free imagery. So if you have used remote sensing before, one of the obstacles of optical remote sensing, basically just like our camera. If you have cloud, you have obstacles, you're not going to get things behind the cloud. So this is a very common issue. But if you use Google Earth, you probably notice that most of the imagery on Google Earth looks like perfect, cloud-free. But in reality, those are not the original image. Actually, this is before, and then if you apply Earth Engine, this is what you get after you do some processing using Earth Engine. Because if a time series, a stack of imagery, and you can do some operation, for example, you just take the median, and then most likely this will get rid of the cloud, and then to give you the cloud-free imagery. So this is just one very common example that you can create using Earth Engine. And most likely this is only just a few lines of code. Very, very powerful and easy to do. One of the biggest advantages of Earth Engine is that it has a huge data catalog. So right now it has more than 30 petabytes. So 1 petabyte is 1,000 terabytes. So think about that, more than 30,000 terabyte of data in the cloud. So you don't, in the past, we have to go to different agencies, NASA or USGS or NOAA, to download the data to our computer and then to do processing. Now you don't have to, everything is in the cloud. You just need to know what's the ID for that specific image. So it's just like every human being in the cloud. You have the name, and then you can code it. Oh, I want you to help me do this. I want you. And then you just put things together, and then you can do computation. So you have all kind of sets, like for example, lane set Sentinel mode is, you can also have a climate or weather data or lane use, lane cover, you name it. If the data that you want not available on the in the data catalog, you can also upload data to your account. So each personal account has 250 gigabyte for you to upload. So it's most of the time it's sufficient for you to do some geodata processing. And this is the JavaScript code editor. So this if you have used this before, this might be very familiar. So basically, you write the source code here in the code editor, and then the result of the data set will be displayed at the bottom here on the map. On the left side is where you save your script. You can also source documentation. On the right here is basically when you query the data, it's going to return some results. So you will display the result on the right in here. And Earth Engine provide two APIs, so the JavaScript API, also the Python API. But there are pros and cons between these two. So JavaScript API is easy to get started, and most of the Earth Engine documentation is written in JavaScript API. There are not many tutorials for Python. Also, but on the other hand, Python is very easy. Most people learn Python first. So and there are lots of IDE to choose from. You can also have a lot of options for you to visualize the data. So you can also integrate with deep learning or local data set. I don't need to get into detail, but this slide here shows you the motivation why I developed the Geemap package. So if you see from here, Earth Engine has the API. So the API the functionality can be grouped into two categories. One is doing computation, and the other one is doing visualization. So JavaScript API has both. You can do computation. You can also do visualization, so display the map interactively. For Python API, you only have computation. You don't have visualization. So that's why I create the Geemap package to fill the gap. If you see from this slide, right, you can write source code using Python API, but the Python API does not provide you how to display the data interactively. You cannot query the API in the Jupyter node. You cannot display the result. You cannot click your mouse to get the data. Okay, so everything here in the red cross, these are the things right now I implement in the Geemap, so that you can easily have the same functionality like what you are doing in JavaScript API. So hope you get the idea, like why I do this, why it is useful. Okay, so now let's get into the package. So what exactly is Geemap? It's a Python package for doing interactive mapping with Google Earth Engine and IPyLeaflet and IPyWidget. So if you see from here, IPyLeaflet basically is a Python package for doing interactive mapping. So basically you can zoom in, you can zoom out, but keep that in mind, it's a general Python package for displaying data, but it's not for displaying Earth Engine data. So it doesn't have the connection. So the Geemap basically is built on top of the Python computation API, and also utilize the plotting backend, and then so that you can have communication between these two. So right now you can display Earth engine data using IPy leaflet. The other one very important is called IPy widgets. So IPy widget I'm going to show you later. Basically, you can create a button, you can create a drop-down list, you can create a text box so that people can enter, or you can select from a drop-down list. So these are all using the so-called IPy widget. And the package is open source, hosted on GitHub. You're welcome to check out the webpage. Also here, I list some of the key dependencies. Again, Earth Engine API is for computation. IPy leaflet is for doing plotting. But I also use the one called Folium. Ideal situation, we only need one plotting backend. But the reason I use the Folium is to support Colab, because Colab currently does not support IPy leaflet. So IPy leaflet is a little bit more advanced, and Colab does not support this one yet. So I have to use the Folium because many people use Folium, and so I'm going to show you the examples later. IPy widget, again, I already mentioned, for creating buttons and drop-down lists or something like that. BQ plot is for doing plotting. So when you want to plot out the spectral signature, then you need some packages to display that one interactively on the map. The last package here is called Voila. So Voila is the package that you can turn a Jupyter notebook into a standalone web application. So for example, after you write your source code, you have the Jupyter notebook, and then how do you publish this one on the web so other people can also, without coding skills or without Google's Engine account, they can also utilize your application. So these are some of the key dependencies. And so it's a Python package. I provide a couple of ways for you to install. You can install using pip or conda or GitHub, and you can also update the package. So I have the tutorial here. If you have never used conda before, you don't know how to install, you can follow my video YouTube tutorial to install the package. Also, I provided Docker image, but this might be a little bit too advanced for you guys. But if you're interested, you can go to the link to explore this one. So Docker image is good for something that might only be available in Linux operating system. If you're using Windows, you might want to use Docker because it's like kind of a simulated environment in Linux. Okay, so next I'm going to show you how to use this one, Geemap in Colab and Jupyter. So if you're using Colab, if you see from on the left side here, Colab is the advantage that you don't need to install anything on your computer. So you just need a Gmail account and then you can open. Again, I want to highlight that in the Colab, we use the Folium Python package. We don't use the IPy leaflet. So it has very limited functionality for interactive mapping. So basically, you can get the Earth engine data and then can display the data on the map. You can do computation, you can display the map, but you cannot really query. So if I click my mouse, I want to get the value of those pixel values, you cannot. Okay, so this is kind of limitation, but I provide this example in here. And on the left side here, I also provide you a Jupyter notebook example and also a video tutorials how to get started. So if you've never used Colab, you can check out the tutorial. So in here, I'm going to show you quickly. Once you click the link, it will take you to my GitHub repo. And here is a simple example. On the top here, you see a couple icons. So all you need to do is just right click, and then you can open this one directly within Colab. And as you can see from here, this is kind of a simple example. First, since the package is not pre-installed by default in Google Colab, so the downside of using Colab is that you need to install the package every time. So, but most of the time it's pretty quick, so it might take a couple of seconds, but you have to install. So on your local computer, you don't have to install. You just install once, and then you are good to go for next time. And after you install the package, if no like errors or anything, then we can continue to the next one. So we can import the Geemap library. So if you see from here, you need to import the Earth Engine API, and very important, this one. Okay, don't import Geemap. It doesn't work because that one use the IPyDeeplet. So make sure that you import the Geemap.ee volume as this one. Then you will be able to do the steps later. Once you import the package, then you can create a map. So in here, let me see here. Let me stop. So as you notice in here, every time when you create a map, you need to authenticate. So I would highly recommend that you mount your drive before doing this, because if you, let me click this one in here. So click to Google Drive. The reason for this one is every time when you're trying to create to use Google Earth Engine, you will need a so-called credentials or Earth Engine tokens. So you ask you to log into your Gmail account and then have a credential, and then can copy and paste it back to your Colab in here. You need to do that every time. It's very annoying. So if you mount your Google Drive, and then if you authenticate, you only need to do that once. So in the future, if you load a Jupyter Notebook, Colab, you just click, and then you don't need to authenticate every time, because the credential is being copied to your Google Drive, and then from your Google Drive, every next time when you open Colab, you will copy the credential from your Google Drive to Colab. So in that way, it will save you a lot of time. Okay, so let's do this one more time. Mount the Google Drive, and then run the source code, and then run this one. So now you will see it doesn't ask you to log into your Google Earth Engine account anymore. And then you can click this one to load Earth Engine data. So if you see from here, we load an Earth Engine image, and then we set the visualization parameters, how we want to display the map. And then you can add some points or whatever you want to do. Then we add the data as a data layer to the map. And lastly, okay. So as you can see here, right now you see the map, right? Interactive. So this is how easy it is. On the upper right corner here, you can turn the layer on and off, right? We have the DM, we have the point, right? The mountain Everest, the highest point on Earth. So again, if you can clear the output, and we can do this one more time. So we can run all again if you want to. But for the first one, you don't need to run every time. If you install, if you're still on this Colab notebook, you don't have to install it again. But this will be the same. So you can change, you can customize whatever way you want. So this is how you can get started with Google Colab. You can add more data set if you want. You can change the data layer names if you want. So easy customize. One thing I would like to point out is that make sure here you have the map.add layer control, because if you have multiple data layers, you want to see this one. If you see my screen here, this is the layer control. If you don't have this one, you won't have this layer control. So if I control/, I comment out this one, and then if I do this, because I already added, so it's still here. But if I run this one again, for example, run over again, and if I scroll to the end, you won't have the layer control, right? So if you have multiple layers, make sure that you add the layer control before you display the map. Okay, so this is how you can get started with Colab, and all we need to do is just to follow my template in here. Install the package, import this one, and then create a map. What you want to customize something in here. So this is what you want to do. You want to analyze anything, you want to add any data set, you change the source code within this code block. And the beginning and the end is pretty much the same. Install package, display the map. But somewhere in between, there are a lot of things you can do. It depends on what your application requirement. Any questions so far? No? Okay, so this is how you can use Colab, and the other one is Jupyter Notebook. So if you are familiar with Jupyter Notebook, you can install that one on your local computer. Then you have the so-called full functionality. I'm going to show you later, but if you see the differences in here, is that you don't need to install this one every time, right? Once you install on your computer, it's forever. And you also, when you import, right now you can just import Geemap, okay? On Colab, you need to import the volume. And lastly, you don't need to have the map.add layer control. by default, you want to have the layer control when you use that one. So it's a little bit shorter. And if possible, use iPyLeaflet. And also have a short paper that you can, if you want to learn more about the package, you can go to the link to read a little bit more about the package. And next, I'm going to introduce the documentation. So it's a package. I have a lot of functionality. You can go to the link here to check out some of the tutorials and the information about the package. One thing I would like to point out is that if you're really interested in programming, you can go to here, and then because we have hundreds of functions, you can click each function to look at the source code behind. So if you want to know, for example, how this package is being built, why each function is doing what, you can go to the website and then look at the source code. You'll be able to reproduce exactly how I implement the package. And I also provide a lot of tutorials, video tutorials. You can go to my YouTube channel. So far I have 37 videos and the total length of 9 hours. So because today we don't have enough time, so I won't go into the details, but you are welcome to check out the tutorials to learn more about the package. And so here is the list, 20 on the first slide and the others 16, so 36. For each tutorial, you have a full-length video. So each video usually is 15 to 20 minutes, and also have a GIF animation. So that one is usually 20 seconds to 40 seconds. So if you don't have time to watch the full-length video, you can watch the animation just for highlights to look at, okay, what this tutorial is actually doing. Also the notebook example, so you can, everything is reproducible. So what I put out in the tutorial, you'll be able to get exactly the same because the source code is open source and provided in here. So you're welcome to download the notebook to your computer and then run that one on your Jupyter environment. So lastly, about the Geemap, I would like to show you some of the key features that what you can do with the Geemap package. So first one is how to do the conversion between JavaScript and Python. So if you get started with Earth Engine, most likely you will, because most of the documentation was written in JavaScript, so you probably have used the JavaScript code editor. But if you want to get started with Python, then if you already have the JavaScript source code, you can just use the Geemap to automatically convert JavaScript to Python. So you don't need to actually write any source code. You just copy the source code from the documentation and then paste it into Notebook and then call the function, and then you will automatically convert the source code to Python. So very easy and straightforward. Again, you can watch the video and also look at the Jupyter Notebook, how to reproduce what I show in here. And the next one is how to source data. So again, I showed you earlier that it has 30 petabytes of data in the Google Data Catalog, but how you can actually load the data into the map. So I show you example here. For example, you're interested in land cover or US Census data. All you need to just do type keyword and then search, and then click the button to just to import. We generate a code block beneath the map, and then you just execute the code block. Then the data will be displayed on the map. So no coding, no coding. So very easy to do. Similar to the JavaScript API, you can also source dataset and then import the dataset to the map. You can also source API documentation. So like this one here, if you use the JavaScript API, you know that you can source those. You can do the same thing in Jupyter Notebook. You can also import dataset from your personal Earth Engine account. So if you have already uploaded some data to your account, you can also use this one to display the data. Also, you can add base map. So this one is not available in the JavaScript API. There are lots of internet web services published on the internet. Sometimes if you want to bring in some base map, this is the best way. So you don't need to download anything. You can just use the built-in. I think right now I have 30 or 40 base map that you can choose from. So you can bring in, for example, Google Map or Bing Map or Esri Map base map. Anything you want to as the base map, so they can compare the base map with your remote sensing data. And this one is also very useful if you need to compare things before and after. You might have seen this one on social media or on news outlet or newspaper. For example, you have urban growth. You want to see before 30 years ago or 30 years later. You might also want to evaluate, for example, natural disasters before tornadoes or after tornadoes, wildfires before and after. So this is a good way that you can visualize the data. You only need one line of code, okay, to create a map. Like this is the source code. If you see here, 3 lines, you can get a map like this. Very easy to do using Geemap. You can also use the inspector. So earlier, like I mentioned, this is only available in iPad leaflet. You won't be able to use this one in Google Colab. This one, if you click your mouse, it will query the data and then return the result and then display here to you. So for example, you click your mouse, it will select the polygon or select the raster behind, and then to get the value return, so that you don't. This is just like ArcGIS or QGIS, very similar, but it's in the cloud. You can return the result from the cloud. And you can also do interactive plotting, right? So for example, Landsat data, 7 spectral bands. You can click your mouse, get a pixel, and then get the pixel values. You can also do that for hyperspectral data. If you have hundreds of spectral bands, you can also do the plotting like this. So this one is using the so-called BQ plot, also very useful Python package. So this one also does not need coding. As long as you add the data to the map, you just activate the inspector and then just click your mouse on the map. You will be able to query the data. And if you also want to, after you query the data, you might want to export the data to your local computer. So like in this case, if you need to collect some training data, you click, and then you can use one line of code to export all the data to your computer. So like by pixel, and then different spectral bands. So if you look at this one here, right? So B1 to B7, very easy to do, and one line of code. So this one is similar to this split panel map, but I built in some of the common imagery. For example, Landsat data since 1984. So you don't actually have to compose the data by yourself. I have already created the annual data. All you need to do is just to create the map and then call the function. And then automatically you can draw a rectangle anywhere around the globe to retrieve the satellite imagery for the past 35 years and then give you the best cloud-free imagery for that specific location. In that way, you don't have to go and to filter the imagery to create a mosaic. So very much simplify the process or the lines of code that you need to write if you use Geemap. You can also do like a marker cluster. So this is also something very useful. If, for example, if you want to display all the US cities, right? You have too many points, it might be very crowded, and you can use the Geemap to have the marker cluster. So you only zoom to a certain level, then you will display all the points on the map. And you can also create animations. So this is, for example, the temperature for one day, 24 hours. So you can see from here, right? You can use this to, the data is from Google's engine. So you can composite the data, and then you can add the time stamp to each imagery. And then you can add, for example, logos. You can add, what's this one? Legends or color rent to this one. So also the text. So everything here can be customized. You can look at my Jupyter Notebook example. You'll be able to do exactly the same thing like what I get in here. Also, if you after you do your project, for example, you want to show the project to your parents or to your friends, they might not have skills to use Earth Engine. So you can use this one to publish your map, and then can embed this one on Twitter or onto a website. Only one line of code. So once you create a map, for example, if you use Google Colab, and then you already create a map, like earlier I showed you how to use Colab. So once you have the map, you add another line of code, and then this one can be exported as published to the web. You copy the link and then paste the link on social media, and then the link will become an interactive app. So very useful. Again, watch the video if you're interested in how to do this one. This is probably the last key feature I'm going to show you. So this is the one that I earlier showed you how to create the animation, surface water dynamics. If you want, you can try out the app here. Click the link, and it will bring you to the web app. So this one actually is a Jupyter notebook, and then basically it's executing the source code, and then to present you the results. And you can deploy the Jupyter notebook to the internet. I'm using like free service, so if too many people are accessing this app at the same time, sometimes the map might not load correctly. So just let you know, it is not like the app is not working. It's the free stuff, so the server is too busy, it might not load the data. And if you see from here, right, this is just the map interactive. This is using the IPyLeaflet, and beneath here you can customize these parameters. If you want like different bank combination, you can change the name. So let me see in here, and if you see from the app, in here you don't see any source code, right? So this is the notebook actually behind. I can show you what the source code look like. This might be a little bit complicated, but you don't have to go through the source code. So I can hide the source code, and this is exactly what I did earlier at the slides, show you how to create this one, right? So very simple, easy to do. The title here is this one here, showing this. You can change the text, and the bank combination is there's so many options you can customize. Okay, and the start year and end year. Start year is 1984, starting from Landsec 5, and then up to 2019. So probably later I can add to 2020 once the year is over. And the font size is how to control this one here. The font size, you can change the font color. This one use white color. You can change to black. You can change to red. You can write any color in here, or you can just select from here if you want. You can also change the progress bar. So this is the here. If you see from this one here, blue color, this is the progress bar. Okay, you might see lots of black and cloud. That's normal because in some area you have clouds throughout the year. The image you're going to get at the end, you're going to still have some clouds, but you can clearly see the changes of the surface water. So this is very, very powerful. That you can. This is just the animation. We haven't done any analysis yet. You can do analysis based on the animation that you get. So next, I'm going to show you like on the fly how I can do this. So for example, right now we're in Las Vegas. Okay, I'm interested in analyzing the urban expansion. So all you need to do on the left side, click the rectangle, and you can draw anywhere you like. Okay, I'll draw a rectangle. In here, I can change the bank combination. So I'm going to use near infrared and red and green. Everything else I can change. For example, Las Vegas. Okay. And you're welcome to change to other things if you want. So I change to white color and blue, and then just hit submit. And as you can see from here, it go to Google Earth Engine, ask Google Earth Engine, and to composite all the data year by year, and then get that one as an animation, download to my computer, and then I use some post processing to add the timestamp and the text to each time frame. At the end, it will add the animation back to this application in here. So if you see at the bottom here, it's like it's working, but this is the link. So basically, automatically download the data generated by Google's engine, and then add animated text. Now this is what you see. So again, very simple, and you don't need to write any source code. And you can do it for any location around the globe. And you can zoom in, you can zoom out, you can clearly see like the urban expansion in Las Vegas, and also the changes of the reservoir, right? It's shrinking and expanding. So you will be able to produce this one later after you finish the presentation, so you can explore any other location you are interested in. And let's come back to here. So that's all for the Geemap. And if you have any questions, later we can discuss. Like if you have any difficulty. Next, I'm going to show you some Earth Engine app. This is using the JavaScript API. So this one is not using Python. But the nice thing about the Earth Engine app using JavaScript, because it has a built-in authentication. So You don't need to deal with how to authenticate Earth Engine. So it's very easy to do. I provide some example in here. You can click the link, and I can show you some example, like some of the things that I developed. For example, if you click this one, NDVI, like USDA 1 meter resolution for the entire US, right? And on the left side here, you can select what year do you want. On the right side, again, so left and right, right? You can zoom in and zoom out. I can show you the example. So this is the very high resolution 1 meter, so much better than Landsat. And if you want to visualize the changes on the landscape, this might be something interesting to see. I'm not sure if you noticed the water, right? In the dry period, this is like disconnected, right? These are wetlands. But if you, during the wet year, you see they're all connected. So this is the whole ecosystem. You can use Earth Engine to analyze how the surface water is changing and how does that impact the environment or the society. And this is for the entire US. So you can zoom to any location you want, but you might need to change the, not every location has data for every year. So you might need to change the year in order to load the data. So similarly, for example, if we're interested in Las Vegas, I'm not sure what year of data we have. If it doesn't load the data, okay, 2017. So we do have the data for 2017, but we don't have data for 2009. So we can maybe change to 2010. Take a look. Okay, so 2010 we have the data, and 2017. So 7 years. If you want to see like what changes, you want to visualize. This will be something that you can. Since it's very already urbanized, so you might not see a lot of changes, but at least you can see the color and others, right? So on the left side here, for example, on the near the reservoir, right? So clearly you can see some of the changes in here after 7 years. Okay. Anyway, so again, you can see here, no coding. Anyone can go to the URL, they can visualize. So it's very powerful. You can develop some app like this very easily. And I also have some other apps, but I don't have time to get into everyone. You are welcome to explore and see if there's anything that you are interested. Okay, so let's do for the JavaScript Earth Engine apps. And the last one I'm going to show here is the QGIS plugin. So you can also access Earth Engine data in QGIS if you know how to use QGIS. And QGIS is open source GIS software. So you might have used Esri or ArcGIS. So QGIS is the counterpart in the open source. It's also very popular. And you can install on Windows or Mac or Linux operating systems. And once you install QGIS, you can go to here, the plugin, and then you can search the plugin and then you can install. Once you authenticate, you're able to do the same thing like in the Jupyter Notebook. You can write the source code and then you can access the data. I think here I have the demo here to show you like how you can, if you have some source code written in JavaScript and in Python, you can load the source code directly to the command window in here. And for example, this is like Earth Engine data. So only a few lines of code, you can bring the data in the cloud to your desktop GIS, and then you can do all kind of computation or visualization. So it's very, very useful. If you don't know how to write the source code, you can go to my GitHub repo in here. This one, I provide almost 300 examples. So all you need to do is just download the examples to your computer and then just follow the demo to load the example to QGIS. Just hit run, and then you will get the results. So check out the repo. And what else? Lastly, if you have time, you want to learn more, you can go to the other repo. So this one has 360 examples. Emulate the Earth Engine JavaScript documentation. So I have converted almost the entire Earth Engine documentation, the user guide, from JavaScript to Python. So you don't have to spend time to convert those by yourself. You can download the repo, and then you can use that one on your local computer. If you want more tutorials, if you have any issues using the Geemap package, you can go to my GitHub repo. You can submit a feature request on the GitHub repo, or you can leave comments on my YouTube channel or on my blog. I'm happy to answer any questions that you might have with Geemap or Earth Engine.